Okay, so here's this proof for the statements of Lem1. So we're going to go through the first three and then I'll do the fourth one in the next video. First two statements, pretty straightforward. So to verify the first sentence, all we have to do is swap the two rows that are the same. When we do that, remember, that changes the sign of the determinant of the matrix. But in this case, it doesn't change the matrix at all, so the determinant is unchanged. So the only value of the determinant that you can change the sign and still be the same is 0. So therefore it must be 0. For the second sentence, it's pretty much the same sort of thing. If there's a 0 row, then all we have to do is multiply that 0 row by some non-zero scalar, for example, 2. Other than 1. We don't want to do 1 either. 0 wouldn't work either, so let's use 2, right? Well, what happens is this doubles the determinant, as we've seen from the properties. So if it doubles the determinant, but in this case again, you're multiplying a 0 row by 2, it doesn't change the matrix. Therefore, it doesn't change the determinant. Even though we're multiplying by 2, and we know that that doubles the determinant, well, the only determinant that we can double without changing it is 0. So therefore, it must be 0. Okay, now, for the third statement, we're going to do Gauss-Jordan reduction. So if we do the Gauss-Jordan reduction for t, right, to go to t hat, so say that t hat is some in echelon, reduced echelon form, let's say. By the first three properties, the determinant of t is 0 if and only if the determinant of t hat is 0, right? Because the determinants won't change because we've gone through those properties, right? Now, a non-singular matrix T, if you Gauss-Jordan reduce it, it will reduce to what? The identity matrix, again, one of the properties. So we know the identity matrix, the determinant of the identity matrix is not 0. And so it has a non-zero determinant. Now, it's an if and only if. So let's do the contrapositive to go the other direction. Let's look at the contrapositive. And I don't have it written here, but I'll just say it, you write it down. If the matrix is singular and you do Gauss-Jordan reduction, then you're going to end up with a 0 row. And if you end up with a 0 row, you're going to end up with a 0 determinant. Okay? And so that proves the result of sentence 3. And now we'll come back in the next video and wrap it up and take care of sentence 4.